Hello everyone, my name is Suram and I welcome you all to my YouTube channel. In today's video we are going to discuss about the chapter Matter and its Composition, that is of standard 7th, subject Chemistry. Matter and its composition. So in this chapter we are going to discuss about the matter and its state and the interconversions of the different states of matter. So very first, we people are watching the different things around us. Some of the things are very big and some of the things are very small, some are very heavy, some are very light. All these things we can feel, we can touch, we can smell. Why it is so? Because these all things are matter. So matter, what we can say that what is matter? As from your previous class you are having the knowledge about the matter, that is, matter is anything that occupies space and which is having the mass, that is known as matter. All that things which are having this mass and which occupies space, that all things are called the matter. All the things around us, even our own body also, that is made of matter only. So all the things which are having these two things, space and mass, which are having the mass and which occupy the space, these are called the matter. So space that anything occupy, that is known as its volume. The space occupied by the body is called its volume, is it? The space of the football is more as compared to the tennis ball, is it? And the mass is the amount of matter that anything contains, that is known as its mass. Mass is the amount of matter contained in a body. So if the mass increases, the weight of the body will also increase, is it? A full glass of water weighs more than a half glass. This you people all are knowing. So all things are made of matter. So can we say that air is also a matter? What do you think, that air is a matter or not? Air is also a matter. We can conclude that air is a matter also, is it? So that is by using this following activity. For this we will take a scale and tie it with the string from the middle and tie the two balloons on both the sides, two inflated balloons on both the sides, and hang this scale with the string, is it, from the middle. And if one balloon get burst, you will see that scale will dip down from the balloon which is filled with air, is it? What it shows, when we have filled the air inside the balloon, it has increased, its size has increased, is it? So it means air is occupying the space, is it? Air is occupying the space. And when one balloon gets burst, you might have seen that one end of this scale will dip down. What it shows that the air has the weight also, means air has the mass, is it? So this activity shows that air inflated balloon is heavier than the deflated one, is it? So what it shows, air is also a matter because it is occupying the space and it is having the mass also. So from here we can say that air is also a matter. So we are having the different states of matter. We are having the solid state, we are having the liquid state, and we are having the gaseous state. So one more state is the plasma state that we will discuss, that is not in your syllabus. So we will discuss about the states of matter: solid, liquid and gas. Three are there. Ice, water and water vapors. Ice, water and water vapors, all are water only, but are of different states. Ice is in the solid state, and water is in the liquid state, and water vapor is in the gaseous state. So which is the thing, what is the thing which causes the states of matter? So matter, as you know, it is not continuous. It is made of the small particles, that is called the molecules. Matter is made of very small particles, that is known as molecules, and there is some space in the molecules that is called the intermolecular spaces, is it? And the molecules which are held together by some forces, that is known as the force of attraction, intermolecular force, or it is called cohesion or cohesive force. So it is easy to understand that the greater the cohesive force, the smaller is the intermolecular space. Means much closer is the molecule to each other, then much stronger will be the intermolecular force. So for any substance, the intermolecular space is minimum, then it is in the solid state, and if it is large, then it is in the liquid state, and it is largest, then it will be in the gaseous state. That depends on the intermolecular force or intermolecular spaces between the molecules. So we can say that the molecules are held very loosely in the gaseous state, and little strong in liquid state, and highly strong in the solid state. So these are the intermolecular forces or cohesive force which determines the states of matter or the intermolecular spaces. So we have the different states of matter. So if we compare all these three states of matter, first is the solid state, then liquid state, and then gas state. So if we talk about the shape and volume of the solid state, a solid is only hard and has a fixed shape and volume, is it? Why it is so? Because the molecules are tightly held together and they cannot move closer or they cannot go away from each other also, is it? If we talk about the compressibility of the solid state, a solid is practically non-compressible, because as we have discussed already here, the molecules are very tightly packed. They can't go closer or they can't go away from each other. So solids are non-compressible, you can say. The compressibility is 0. Fluidity means they can flow or not. So a solid do not flow, is it? A solid, when it comes in liquid state, when it melts, only then it can flow, is it? So solid do not flow. So it may be knowing the reason why it is, because the molecules are held very tightly. Intermolecular force is very strong. So if we talk about the liquids, shape and volume, liquid has a fixed volume but not a fixed shape. It takes the shape of the container. You might have seen when the water is placed in a glass, it will take the shape of the glass, and if it is placed in the bucket, jug, pitcher, whatever the vessel we are placing the water, it will take the shape of that vessel only, is it? So liquids are not having a fixed shape, they are having a fixed volume only. Compressibility, liquids are compressible to a little extent. We can compress to a little extent because their molecules are having some gap between each other, so they can be compressed to a little extent, not too much, to a little extent we can compress it, liquids. And if we talk about the fluidity, as you are knowing already, the liquids can flow easily. So if we talk about the shape and volume of the gases, so gases has neither a fixed volume nor a fixed shape. The shape and volume is not fixed in case of gases. And if we talk about the compressibility, so gases are highly compressible. What is the reason behind it? Because their molecules are quite away from each other and they can come close to each other also, then they can move away from each other. So that's why the gases are highly compressible. So if we talk about the fluidity, so gases can flow easily, that you are knowing already, and it is a natural tendency of the gases to flow from higher pressure to the low pressure zone. So intermolecular force is larger in the higher pressure zone and it is lower in the lower pressure zone. so that the gases can flow. So this is the comparison between the different states of matter. So next we have the expansion in the different states of matter. Thermal expansion. So thermal expansion is what? It means the expansion on being heated. If we heat the solid, you might have seen that it will expand. So a railway track, you might have seen here, railway tracks will get bent if the no gap is kept between the two rails, is it? So thermal expansion of solid is very small, then that of the liquid is larger, and that of the gases, it is the largest, is it? So solid expand to a later extent, is it? Liquids to some large, and the gases is the largest. So on being heated, the molecule absorb the energy and they move farther apart. So the smaller the intermolecular force, the farther the molecule will move, is it? So in case of gases, the intermolecular force is very weak, so that's why they can move away from each other easily, is it? So their expansion is largest. So you can get the idea about the thermal expansion by the different activities. We can discuss about the activities in case of solid, liquid and gases. Expansion in the different states of matter. First is the solid. So here you can say, if you take one ring and one strand and hang a metal ball, and the diameter is almost equal, and the ball is having slightly less diameter as compared to this ring, so that it can easily pass through this ring. So firstly, when the ball is cool, you will see this ball will easily pass through this ring. Before heating, is it? Before heating at the room temperature. So once you heat this metal ball, you will see here it will not pass through this ring. So what it shows, that on heating this ball, there is expansion in this metal ball and its size will get increased. So because of the expansion, this will not pass through this ring, is it? So it means solid has expanded because of expansion because of the heating. And if we talk about the liquid also expand differently. If we talk about the different liquids here, two liquids we have taken here, water and alcohol, and initial level of this two is same. Here is the initial level of alcohol and water, and if we heat it, then you will see the level of water is rising to some extent and the level of alcohol is rising more, is it? So it means when the liquid is also heated, then expansion will take place in case of liquid also, is it? So this is liquids also expand on heating, although the expansion is different in the different liquids, same is in the case of solid also. Actually the expansion depends on the nature of the solid or nature of the material also. So if we talk about the gas, expansion also take place in the case of gases. Take a empty bottle and fix a balloon on it, on the mouth of this bottle, and deflated balloon, and keep this bottle inside the tub and heat this tub containing water. You will see as the water will get heated and the air inside this bottle will also get heated, and because of the heating the air inside this bottle, it will expand and the balloon get inflated. Because of the expansion, the balloon will also get expand, is it? So this shows that gases also expand on heating. So these are the expansion in the different states of matter. So there are the changes in the different states of matter. So we'll discuss one by one how the changes take place from one state to another. Solid on being heated, it changes into liquid. So the temperature at which the solid melt, that is called its melting point, and the liquid on cooling also gets solidified and it becomes solid. That is called the solidifying or freezing. Liquid can also convert into solid again, that is on solidifying, or it's called the freezing. And the temperature at which the liquid freezes, that is called the freezing point, is it? So liquid can also be converted into gas, that is by the process boiling, and the temperature at which the liquid boil, that is called its boiling point, is it? And gas can also be converted back into liquid, that is known as the condensation. Gas on cooling converts into liquid. You might have seen the water droplets when a lid is kept on the container in your kitchen also, is it? When you have the boiling water, and if you cover it and take out the lid, you will see the water droplets on the lid also at the back. That is because when cooling takes place, the gas converts into liquid. That is the by process of condensation. And gas, solid can directly be converted into gas, that is by the process sublimation. It is called sublimation. Solid directly sublimes to gas without converting into liquid state. Solid can directly change into gaseous state, that is by the process of sublimation, is it? And gas on cooling will convert into solid again, that is known as desublimation, is it? So these are some processes of change of state and the different states of matter. So this you need to remember. Next we have, are the vapors different from the gases? What do you think? The vapors are different from the gases? The vapors are same as the gases, but substances that ordinarily exist in the gaseous state are called the gases. However, the substances that ordinarily exist in the solid state or liquid state, that are called the vapors in the gaseous state, is it? For example, the sulfur that is ordinarily a solid is called the sulfur vapor, is it? And water that is ordinarily a liquid is called the water vapor, is it? So that depends on the states of the substance, whether it is in solid state or in the liquid state. Next we have the composition of matter. What is the composition of matter? Matter is made of elements, a substance that cannot be split into simpler substances by chemical means, that is known as an element. Like elements, there are the different kinds of elements, is it? Basically hydrogen, nitrogen. Some common examples are hydrogen, nitrogen, oxygen, carbon, sulfur, copper, krypton, etc. These are all the elements. So they are represented by the symbols. Like you might have seen the Kr. There Kr is the symbol for the krypton. Then next we have the composition, that is compound. Compound is what? A substance that can be split into simpler substances by chemical means, that is called a compound. A substance that can be split into simpler substances via chemical means, that is called a compound. For example, sodium, chlorine. When sodium combines with the chlorine gas, it forms the table salt. So that can be, that salt we are using for the different purposes, is it? So that is a compound. For example, sodium combines with the chlorine to form the common salt, that is the sodium chloride. Then next we have the atoms and molecules. These are the building block of matter, you can say. An atom is a smallest part of an element that takes part in a chemical reaction. It is the smallest part of an element that take part in a chemical reaction. A molecules is the smallest part of an element or a compound that is capable of independent existence. That is known as the molecules. atoms and molecules. So atoms combines in a fix whole numbers to form a molecules. Is it? Atoms combines with each other to form a molecule. For example, the molecule of water. In the molecule of water, we are having the 2 hydrogen and 1 oxygen, that is H2O. Is it? Hydrogen is represented by the formula H2. Is it? The molecule of nitrogen, oxygen, chlorine, they are represented by the formula N2O2 Cl2 respectively. However, a molecule of ozone contains the 3 atoms of oxygen and is therefore represented by the formula O3. Is it? So molecules of the compound, they are represented by how many atoms are combined. Is it? So 2 atoms of hydrogen combines here with 1 atom of oxygen. Is it? To form the molecule of water. The formula of water is H2O. Is it? Thus, if the formula of ammonia is NH3, is it? So you should be able to say now that 3 hydrogen atom combine with 1 nitrogen atom to form the molecule of ammonia, NH3. Is it? So remember that if the sample of element of a compound is pure, then the formula of its molecule does not change. Is it? So this means that the number of combining atoms will remain fixed. Is it? So what holds together the atoms and molecules? Atoms and molecules, what is the thing which is holding these atoms and molecules together? So there is a force which is holding the atoms and molecules together. What is that force? That force is called the chemical bond. Is it? The force that holds any 2 atoms in a molecule together, that is known as the chemical bond. And chemical bond is much stronger than the intermolecular force. You might have seen the molecules in a matter is held together by the intermolecular force. Is it? So don't get confused in intermolecular force or the chemical bond. Is it? A chemical bond is the force that hold any 2 atoms in a molecules. Is it? That is known the chemical bond. So chemical bond is much stronger than the intermolecular force. So this was all about this chapter. So in the next video we will discuss about the exercises and the question answers. Thank you.